Good morning, everyone. My title is Computational Image and Text Fusion Modeling for Multimodal Representation and Intent Prediction.
I will introduce my research from these four parts.
Background and an important research direction in the field of artificial intelligence and computer science. Intent detection is one of the core technologies of human-computer interaction, aimed to accurately identify the user's intent from his input to achieve more intelligent service. This is an example of intent detection based on text and image fusion.
What is a modality? Modality refers to some way of expressing or perceiving things, each source or form of information in multimedia according to different forms of information presentation. The modality mainly includes video, image, voice, and text. There may also be different modalities and the same form of information. For example, in text task, we can consider two different languages and two different modalities. What is multimodal? Multimodal refers to the expressing or description of the same object from multiple modalities, such as the below multimodal data of snow scenes, including video, audio, image, and text modalities. From the perspective of model structure, the related works can be divided into manual rules, statistical methods, deep learning. From the perspective of model input, we can divide the related works into single model and multimodal. The manual rules and the statistical methods are both single model. Most of deep learning methods are single model and a small portion are multimodal. From the table, we can see that existing mainstream methods have some obvious disadvantages. Some manual rules are high workload per stability. Statistical methods need a manual feature extraction. Some deep learning methods are only for text, low efficiency. More complex, higher computational and storage resource. Single model methods do not make full use of the rich information of multimedia data, and it's difficult to effectively complete the task in the face of the diversity and complexity of input content. Existing multimodal methods usually use multiple single modality pre-training models for different modalities feature extraction, which not only increase the complexity of the system and the computational cost, and may also limit the model's comprehensive understanding of the context. And contribution in this research in response to these challenges and problems, this research propose an intent detection method based on image and text fusion, inspired by the multimodal pre-training models. We use the CLIP model to achieve feature extraction, alignment, and representation. The model uses contrastive learning to learn the correlation information between modalities in the pre-training stage, so it can better process both image and text data simultaneously and improve the ability of information understanding. And it can also simplify system integration and save computational resource. In this research, we use image and text to achieve intent detection. The main architecture is shown in the figure, which mainly includes three parts. feature representation, filtering, and classification. In the representation part, text and image feature extraction, alignment, and representation are automatically achieved using the clip pre-training model. In the filtering part, considering that different modalities contain different amounts of information and have different contributions to intent detection. So we designed two-level across-modality attention module to fuse character level and global level feature of image and text. Finally, we fused the features finally, the features are input into the classifier to achieve intent detection. In the representation stage, we use the CLIP model developed by OpenAI. It's a powerful machine learning model designed to understand image and textual descriptions. It's trained based on a massive dataset of image and corresponding text captions gathered from the internet, so performs well in text and image processing tasks and achieves state-of-the-art performance in many tasks. We can see from the left figure, this model mainly consists of two parts. Text encoder and image encoder are used to extract text and image feature respectively. The detailed architecture of the image encoder is as shown in the left figure. The detailed architecture of the text encoder is as shown in the right figure. It's similar with image encoder. They both adopt classical transformer structure, or we can get the global level output and the character level output of image and text. In the process of feature fusion, we adopt cross-modality attention uh, mechanism to integrate information of different modalities. Unlike traditional vector splicing method, cross modality attention allows the models to selectively focus on the most relevant parts of each modality. The process of the calculation is as shown in the image. Um, the number of total labels is 20. After data processing, the number of total samples is 2,324. Each sample contains two modalities, information of text and image, as well as the intent label. We divide all the samples into training, validation, and testing sets in 6 to 2. The detailed numbers of samples of each portion are shown in the uh, table. Um, through observation of text results and based on prior knowledge, we set main parameters as follows. Um, experiment part. To verify the effectiveness of the proposed approach, we use three mainstream multimodal methods and two mainstream single-modal learning methods as baseline models to compare the results. Through the comparison with these five representative models, we can effectively evaluate the performance of the proposed method. The above table shows the overall comparative experimental results from the perspective of overall metrics. Our approach shows excellent performance on the intent detection dataset compared with baseline models, which verify the effectiveness of the proposed method.
This part is to verify the improvement of model performance by each module. In this study, ablation experimental studies are carried out for different types of input data feature representation module and the fusion module. And as can be seen from the first two rows, after removing text, only using image data had the worst effect. This shows that text features play an important role in intent detection, while the role of image information is secondary. This is the same as the above experimental conclusion. It can be seen from the third row that it will affect the performance of model if we do not consider the correlation between modalities during feature representation. OpenAI provides two major types of pre-training models. One is based on RNN structure and the other is based on transformer structure. To further explore the impact of different image encoders on performance, we perform a contrastive experiment to evaluate four-man image encoders. Through the experiment, it's found that different encoders will slightly affect model performance, but the overall difference is not obvious. In general, smaller patch can capture more flagrant image features, but the actual effect mainly depends on the specific task and the dataset. Use the confusion matrix to visually show the prediction effect of each intention. To further analyze the case of incorrect prediction in the test data. Overall, the model shows high accuracy in most categories, but there are also obvious differences in the performance of different intents. Some intents have relatively fixed expression patterns and specific content, such as praise, thank, apologize, agree, and greet. And the model shows better performance in these categories. However, in some complex scenarios, such as inform and joke, the model performs generally, which may be because the expression of these intents are diversified and the content is relatively abstract. It can be seen from the confusion matrix that the model is easy to confuse, inform, and arrange. Complain and oppose. These categories themselves have high similarity, which is easy to cause misjudgment. This research mainly explores the application of image-text information fusion technology in multimedia intent detection. In order to better utilize the information of these two different modalities, we introduce a vision language large-scale pre-training model to extract text and image features simultaneously to achieve multimodal representation. Finally, we verified the effectiveness of the proposed method by comparative experiment with the baseline models on the same dataset. But due to the limitations of data resource and hardware device, there are still many shortcomings in this study, and there is room for further improvement, like data size and diversity and other modalities. The missing modality. In the future research, more information can also be introduced from both internal and external perspectives, like user profile features and the knowledge graph. They are also very useful. And thank you for your listening.